Good morning, everyone. Uh, Today we will see the unit number 5. So we'll just start with the contents syllabus of unit number 5. So it's a DC to DC converter. Okay. Before that, anyone just unmute yourself and tell me, am I audible or not? The screen is visible or not, or the sound is proper or not. Just anyone unmute for a minute and tell me, am I audible or not? Yes.
Yes, sir.
Okay. So all right. So we'll start this unit number 5, DC to DC converter. Till we have seen AC to DC converter, then we have seen DC to AC converter, that is called inverter. Now we will see the DC to DC converter. Okay, just a minute. One minute. Okay, so these are the applications of power electronics. As already we have seen the various power devices as a part of your syllabus. So the power devices like power BJT, power MOSFET, IGBT or SCR, GTO, these devices are used in these applications. So first unit is about the introduction of power devices and its construction, working, and its characteristics. Okay. Then in second unit, we have seen the protection circuits and gate drive circuits required for these power devices. Now in unit number third, we have started with the applications of power devices. So first application that we have seen is converter, AC to DC converter, right? So that AC to DC converter basically having maybe a AC input and DC output, that is a variable output. Okay, so output is change or you can vary with the help of changing firing angle. As you increase or decrease the firing angle, you are having maybe a variable output voltage. Okay, so that is the one part. Then second one, that is we have seen DC to AC converter. The main aim is to learn this DC to AC converter is to see how to convert fixed frequency to variable frequency. Then we have to see how to change even output voltage, right? So again, we have seen the various power devices used in these applications. Now this is the next application, DC to DC converter. Again, DC to DC, it means higher DC to lower DC, lower DC to higher DC, right? Or maybe a variable DC. So according to that, the DC converters are classified. But main question comes in mind: what is the need of these DC converters, right? So first of all, these DC converters are required uh, for electric vehicles, not only for electrical vehicles, but in industry, they are required to control the power of or speed of DC motor. As we know that this DC voltage is given to the armature as well as field winding of a DC motor. So you can have variable voltage, so you can easily change the speed of DC motor, so that we require this DC to DC converter. But one of the best example is electric vehicle. So in electric vehicle, we're having a fixed DC voltage from a battery, but you can have maybe a variable speed of a motor, right? Or you can call bike. So that variable speed is achieved from using this DC to DC converter, right? Because the battery voltage is fixed. Okay, if you apply this fixed voltage, then the speed of motor is also fixed. Then the speed of bike is also fixed. So it is very difficult to control the bike by using fixed DC motor. So we required variable DC voltage, and that is achieved with the help of this type of converter called as DC to DC power converter. Okay, so this is the syllabus in front of you. DC to DC converters, working principle of step down chopper, step up chopper, right? Uh, then control strategies, performance parameters, then buck converter, boost converter or buck boost converter. So buck it means down converter, boost it means up converter, and buck boost is up down converter. Then two quadrant chopper and four quadrant chopper. Now what is the two quadrant, four quadrant that we will see later on. But two quadrant, four quadrant chopper is one of the important converter types. An application of choppers, SMPS, buck regulator using TPS 54160, then switching regulator, that is SMPS, and characteristics of standard regulator. Then IC TPS 40200, looped out LDO regulators, IC TPS 784901. So these are the different regulator ICs, right? Even LM35, you know that LM35 is also one of the regulator IC, and which is variable regulator voltage IC. Even 7800, then 787900 or 7805, 7812, 7806, 7905, and so on. These are the various ICs, sorry, various ICs used uh, as a variable or sometimes fixed regulator. So it's a syllabus. I will go for the objectives, what we have to learn. So in this particular regulator or in this particular unit, we have to learn the working principle of DC to DC converter, then various types of DC to DC converters, how the DC voltage is changed, how DC voltage is converted, and so on. So the definition that is given here, chopper is a static device. Uh, Keep in mind, because every time the chopper itself is called as a device. So chopping device, it means your power devices, right? So the component used in this circuit itself is called as a chopper device, or maybe a static device, or maybe a chopper itself. Okay. So that convert fixed DC input voltage to the variable DC output voltage directly. This is DC equivalent of AC transformer as it behaves in an identical manner. If you have seen the practical number 6, the video of practical number 6, in which we are using auto transformer, or we can say maybe a rheostat. So that is not a rheostat, sorry. Uh, it's a basically a auto transformer or variable transformer. So this is nothing but a DC equivalent of AC transformer, right? Because the output is variable. So this will work as in identical manner like DC equivalent of AC transformer. Then more efficient than AC transformer, as they involve in one stage conversion. They offer smooth control, high efficiency, then high fast response and regeneration. A chopper A chopper can act as a step up or step down DC device, right? So a chopper can be operated in either a continuous or continuous current conduction mode. Chopper can be built with and without electrical isolation, and they find applications in trolley, cars, marine, hoist. Then these are the some other applications. Okay. Then basic principle: high speed on off semiconductor switch is used in the circuit, and that switch is operated at the variable frequency so that you will get a variable output voltage. It connects source to load and disconnect the load from source at high speed. Continuous triggering on and triggering off a rapid switching speed. By varying on and off time of SCR, the average voltage across the load can be varied. So as like inverter, again the switches used in a circuit is continuously on and off, and according that you will get a average DC output voltage. When I explain the difference between power electronics and linear electronics, that time I have already explained you the working of SMPS. So working of SMPS is nothing but a DC to DC converter, because the output of SMPS may be a variable output voltage from a fixed DC voltage. So SMPS itself is one of the example of DC to DC converter. Then this is a classification. Class A, also called as a one quadrant operation. Class B, one quadrant operation. Class C, two quadrant operation. Class D is also called as a two quadrant operation. Class E, that is called four quadrant operation. So these are the types of choppers. Based on the output voltage, choppers are classified into step up called as a boost up chopper, step down called as a buck chopper, and buck boost chopper, right? So these are the another types of chopper. Then further classification of a chopper. This is not a part of your syllabus, but this is another classification that I want to show you. So depending upon the power loss occurred during on and off of a switching device, the choppers are classified into two categories. First one called hard switch converter. Another is soft switch converter. So hard switch converter, here the power loss is high during switching, that is on and off and on, as a result of non-zero voltage and current on the power switches. So in this particular converter, sometimes your output voltage is a zero, right? Result of non-zero voltage and current on the power switches. And soft switches or resonant converter, in this type of chopper, the power loss is low at the time of switching as a result of a zero voltage and or zero current on the switches. Okay, so this is the two types of choppers, but not a given in your syllabus. So as per your syllabus, only class A, that is called one quadrant, class B, class C, class D, and class E, and these buck boost converters. These are the types of the syllabus of your maybe part of your syllabus. So this is DC to DC converter technology, linear regulators, switching regulators, and charge pumps. So actually, this is a generalized types of a DC to DC converter. So linear regulators, then switching regulators, and then charge pumps. So some difference is given. You can check here parameter, linear regulator, switching regulator, and charge pump. So efficiency is low of linear regulator, switching regulator is efficiency is high, EMI noise is low, but here it's a high. Then output current low to medium, here low to high. Then boost step up, that is not possible in a linear regulator, but it is possible in a switching regulator. Buck step down is possible in both. These linear regulator, it means the regulators available in our laboratory. So that regulators are not a step up regulators, they are only step down regulators, right? And solution size, small, large, and another is called charge pump. So this is comparison just for your information. These are the different technologies used to convert DC to DC. Okay. Now chopper methods of a control. Now, again, these are nothing but the triggering techniques used to turn on and off the switches used in a chopper circuit, right? So output DC voltage can be varied by the following method. One is called constant frequency control or pulse width modulation control. Another is a variable frequency control. These are the two techniques used to trigger the devices, power devices used in a chopper circuit, right? Because chopper circuit nothing but again a power devices. So that power devices required triggering circuit, and the triggering circuit is maybe either PWM technique or maybe a VFC. So these are the two techniques used in a chopper to control the output voltage. In pulse width modulation, the pulse width T-on of output waveform is varied, keeping chopping frequency F constant, right? So the frequency must be constant, for example, 1K, but on time is change. So if on time increases, the off time decreases. If on time decreases, off time increases, but the frequency remains constant. Okay. So during the one cycle, I'll show you the example of that. See here, this is a PWM converter. So T on, T off, right? So T on is lesser, T off is higher. In the same thing, you can check the T on, T is total T is same. Total T is same, but on time increases, off time decreases. So keeping chopping frequency constant, just vary the on time, right? On time you can say off time also, because when on time increases, so off time decreases, but the frequency remains constant. It means total T remains constant. Okay, you can increase T on like this, so automatically T off decreases. You can increase this T on like this, T off decreases, but T remains constant. That is the first method, right? And in the second method, you can check here, that is called variable frequency. Here frequency changes. So in this method of control, chopping frequency F is varied, keeping either T on or T off constant. This is another method, right? So by changing the frequency, either T on or T off is constant. See, T is changing. Here the T is like this, but here the T decreases. But on time is constant. See, on time is as it is. So keeping on time constant, the frequency is changes. This is called as a variable frequency control, right? So in PWM control, the frequency, chopping frequency is a constant. By changing on time, right? Uh, you can change maybe the pulse width, and in second method, variable frequency control, in which frequency is changing, but keeping one of the time, maybe on time or off time, any one time, keeping constant. Here in this figure, T on is keeping constant and total T is changing. It means frequency is changing. So this is another method called as a variable frequency control, and this one is a pulse width modulation technique. So already we have seen pulse width modulation technique in a previous unit. So we'll go for the principle of chopper operation, right? Now the chopper circuit, which is very simple, you can see the diagram in which only one switch is used. Sometimes two switches are used. In some example, four switches are used, right? So only single switch. So that switch is on and off, and according to that, the output average voltage may be changed. So switch is connected in series with the DC voltage source and load. The switch can be power transistor, an SCR or a GTO, power MOSFET, IGBT, any one switch you can use. As we know that the power transistor, power MOSFET, IGBT, these switches are used for low and medium power, and for high power we still use SCR. Even GTO can be used for medium power, but SCR, no other option to the SCR for high power applications, right? So ideal switch will offer zero resistance. We know that uh, on voltage drop or voltage drop across the switch when it is on, we consider as a zero, ideally zero, but practically it is not a zero. So ideal switch will offer zero resistance in on time and infinite resistance in off time and instantaneous switching, no lag. The switch can be turned on and turned off with the help of triggering circuit and commutating circuit respectively. This is again important because to turn on the SCR is very simple, but to turn off the SCR is very difficult. And this is a DC circuit, so SCR you can turn on with the help of gate pulse. It remains on, right? Because it never turns off. As SCR once turns on, and if it is in a latching condition, after that, if you remove the gate bias, it remains on. So in a DC circuit, if you want to turn off the SCR, then we have to use commutating circuitry. Without commutation circuitry, we cannot turn off SCR. And commutation circuitry is one of the difficult and complicated tasks because we have to turn off SCR. It means we have to minimize the anode current below holding current when your SCR turns off. Otherwise, SCR remains on. And this is a difficult technique, but that is one of the part of chopper circuit that is required. If you are using SCR, then we required a commutating circuit. If you are using IGBT, MOSFET, power transistor, simply remove the base current or gate voltage, then that device automatically turns off. But with SCR, we have to use a separate commutation circuit. Without commutation circuit, you cannot turn off your SCR because the input source or input voltage that is applied between anode to cathode is a DC, right? And once your SCR turns on, it remains on. It never turns off, right? So the method to turns off is to use commutation circuitry, proper commutation circuitry. Otherwise, your SCR never turns off. So every chopper circuit required a triggering circuit and commutating circuitry if you are using SCR. If you are using SCR. If you are using other devices, then no need to use commutation circuit. Simply remove the base current for power transistor, gate voltage for IGBT and MOSFET, right? So this is the most important part that you have to understand, you have to keep in your mind. Remember this thing always because uh, chopper circuit always required a commutation circuit. Okay, and it can be turned on and turned off as desired at very high frequency. So as we know that we are using power devices, so that power devices can be on and off at very high frequency. Whatever you want, you can maybe turn on and off your power device, even SCR at the chopping frequency greater than 500 kilohertz or more than of that, right? So during on period, chopper is on conduction and load voltage is equal to the source voltage. During off period, chopper is off condition, load current flows through the freewheeling diode FD. This is for inductive load. For resistive load, no, right? So for inductive load, load current flows, but load voltage is equal to zero. Result as a load terminal are short circuited by freewheeling diode, thus the load voltage is zero during off period. In this manner, a chopped DC voltage is produced across the load terminal. Chopped, it means a step down voltage is produced. From the T equal to T on plus T off equation, it is clear that the load voltage depends on two factors, the supply voltage and the duty cycle of the chopper. Again, this is very important. From the T equal to T on plus T off equation, it is clear that the load voltage depends on two factors, that is supply voltage and most important, duty cycle. Very, very important, duty cycle, right? So duty cycle of the circuit decide the output voltage, right? So since the supply voltage is a constant, load voltage is governed by the duty cycle only. As we know that supply voltage is a constant, so output is only depends on the duty cycle, only depends on duty cycle, right, of the chopper. In other words, the load voltage is depend on two factors, on and off, T on and T off, right? So hence we conclude that the average load voltage can be controlled by varying the value T on and T off, right? So varying T on and keeping the period time constant. This is called as a constant frequency system or a PWM scheme, and variable frequency system, that is keeping either T on constant or varying T off, or keeping T off constant and varying T on, right? So automatically your frequency is changing. Here duty cycle, we know that T on by T, right? So chopping frequency F equal to 1 by T. Now this is first chopper, that is step down chopper, right? So I'll just show you the step down chopper first. Okay, so first part, but before that I'll just show you here. uh, this is actually a load, right? So here this particular switch SW is a switch. Here a supply is given. This is basically a DC source, right? So DC source, whenever the triggering pulse is applied, that time switch is on. If switch is on, load current flows, right? If it is inductive load, then it will store the energy in its magnetic field with the polarity upper positive, lower negative terminal, right? Now whenever the switch is off, that time this terminal become positive, this become a negative, and this freewheeling diode or your current flows through the freewheeling diode, right? This time the output voltage is equal to 0, but output current is still positive, right? So this is the circuitry. So this is circuitry. First condition what I explain you, when switch is on, that time current flows, it store the energy. When switch is off, that time the current flow through the particular freewheeling diode. So this is the ideal condition first, right? I'll just show you this is ideal condition or maybe off condition. This is a switch on condition. So current flows from VS switch, then inductive load, right? So it stores the energy in its magnetic field with the polarity positive upper, negative lower, right? Then whenever the switch is off, here in third figure, when switch is off, that time the energy stored across inductor is get reversed its polarity. So the anode is positive, so current flow through anode, then inductive load and so on. So output current is constant, but output voltage is equal to 0 because switch is off, right? So this is a generalized block diagram that is shown here in the last figure. Vs, that is DC voltage, the switch, this is called a chopper. So switch itself is called as a chopper. If the switch is closed, then current flow through the load. If switch is up open, then no current flow through the switch, right? If this switch is closed like this, if switch is closed, current flow through this switch to the load back to the DC source, right? So that time output voltage is equal to DC, something DC voltage, which is equal to the supply voltage, right? If the switch is open, then the current will 0, because after this switch current will never flow. So output voltage is equal to 0, and like this. Okay. So this is a simple working of a chopper. Now step down chopper. Output voltage is less than input voltage. So that's why it is called as a step down chopper. Okay. Output voltage is less than input voltage. So it is called as a step down chopper. Also called as a buck converter. Also called as a buck converter. The same is called as a buck converter. The thyristor in the circuit acts as a switch. So thyristor is not shown here. The switch itself is a thyristor, or you can say SCR. If you are using SCR, it means that it requires a triggering circuit, as well as it requires a protection circuit, as well as it requires a anyway commutation circuit. If you are using thyristor, it means SCR, then this SCR required a triggering circuit, right? It required a protection circuit, and it required a commutation circuit. All three circuits are not shown in the figure for simplicity, but we have to consider that without triggering circuit, your SCR never conduct. If you are using power device for high power, it means you require a protection circuit. So it is always there with the power device, but not shown in a figure. And if you are using SCR in a DC circuits, then you require a commutation circuit. That is also not shown in the figure. Okay, but it is always there. So keep in mind, these three circuits are always there. Without these three circuits, your chopper circuit will never work. Okay, but that all three circuits are not shown in the figure. So only one switch is shown. So this switch nothing but your SCR. When thyristor is on, supply voltage appear across the load. You can check here. This in second figure, when switch is closed. If switch is closed, the current flows through the load like this. That time diode is in reverse bias condition. Why? Because the voltage at the anode cathode is more positive, right? So you can check here the negative terminal of battery connected to the anode, right? You can check here negative terminal of battery to the anode and positive to the cathode. So diode is in reverse bias condition, and when it is reverse bias condition, it shows infinite resistance. Infinite resistance, it means open circuit, right? So the diode is shown as an open circuit here. So okay, so supply current flows through the load back to the source. So this is called a closed switch operation. Now when switch is open, as we know that the inductive load store the energy in its magnetic field with the polarity positive here, negative here. But whenever the switch is open, immediately the polarity is changes like this. So this will become a positive, this one become a negative. This positive will appear at the anode of diode, right? And negative to the cathode of diode. So immediately diode turns on and current flows between this particular path, right? So this is the inductor. So inductor store the energy in its magnetic field during on time of a switch. And whenever the switch is off, the polarity of a stored charge get reversed and inductor start to release the energy through this R back to the supply voltage, that is a VDC, and then again back to the inductor energy. Practical arrangement includes an inductor and a diode which are used to eliminate the current pulsation, providing a smooth DC current. With S closed, D is off and it remains off as long as S is on. Then input current builds up exponentially and flow through the L and load V0 equal to V. This is actually a working of this particular circuit, what I already explained you, right? So this is the step down chopper, also called as a buck chopper or buck converter. Okay. So we will see the remaining part, maybe a next part in a next lecture. So last 2 minutes are remaining. So you have to give your attendance, and between this time, if anyone having any question in your mind, you can ask me. And at 3 o'clock, you have an exam of PEA, Power Electronics and Applications. This is the online examination. Total, there are 4 pages. First page is your information, roll number, name, your mail ID. Second page, there are 10 questions on unit number 1. Then third page, there are again 10 questions on unit number 3. And again, sorry, unit number 2 and page number 4. Again, there will be 10 questions on unit number 3. A very simple questions I have asked. So you have to attend the exam, everyone, because these marks are very, very important for you, at least in this corona situation, because we don't know what kind of methodology accepted by university for giving marks. So these online marks, that is internal test, even test 1 and this mock test, may be considered for your internal assessment. And your internal assessment, if you will get good marks, because in the last examination only 2 students, one student was absent and one was failed. Remaining all students got more than 12 marks, that is required out of 30, and most of the students got 25, more than 20 marks. Even some got 28 marks, 27 marks. So that is good. So this time also, the examination is very simple. The questions are very simple, but few questions are there in unit number 3rd, which is basically mathematical questions. So you have to solve the mathematical questions. Definitely it is 1 mark, but by using simple equation, you have to find out the output voltage or output current. So single phase, half bridge, so single phase, half converter, full converter. So on that there will be a simple problems. So keep calculator with you, and the whatever equations I have given in unit number 3rd, on that simple equations, the values are given directly. You have to calculate the output voltage, but everyone should attend the exam